Hey guys, welcome to the third part of MRP. Well, this video is coming straight after the video that we did about exercise 14.5, which is about this company that manufacture a sub-assembly called S. So as I recall, in that video what we did is like this is the solution to the exercise. What we had to do was just to design a product structure of an assembly that is called S, a sub-assembly part that's called S, and then it's a different component T and U. And as I recall, we say that S is the main component, which is also the parent, and it's got different components T, U, V, W, X, Y, and Z. So the number between bracket here tells you the number of units that are required to manufacture every component, and then we identify the different parent and the different level. This is what we did in the previous video. So in this video here today, well, the question is not asking to find for the bill of material, because in the previous question it was asking to construct a product structure to identify all the level as well as the parent and the component, which we just did. So normally in some other exercises they ask you to find for the bill of material. This exercise is asking us to go straight for the term-based product structure. We will do that, but before we do that I wanted us to do a bill of material. Like, I don't know if you remember in the first video, that was the introduction to MRP, which said that the bill of material, it is a bill that tells you how many material you need for every component. So this is what we'll be doing in this part here before we jump to the term-based product structure. So in this case here, how do you go about that? First of all, for you to identify the bill of material, for you to be able to do it, there are information that you need to get, like the initial number of products that need to be made. Like in this case, it's 100 units that need to be made. Like we need the main product to be made here is S, but now they say that we need to manufacture 100 of it. So that information alone is enough for us to allow us to find the bill of material. So the bill of material will tell us how many units we need for every component. How do we go about doing that? So this is what we're doing here. So the bill of material will start first of all with S. The different values that we got on top here, for you to understand where they come from, you need to look at the previous video, which is about the product structure, which is part 2 of MRP. So this part here will start with the bill of material for S. S, initially we're not calculating anything. According to the statement of the problem, we need to manufacture 100 units of it. So initially S is 100 units that are required. Then apart from that, we need now to calculate if we need 100 units of S, how many units of every component. So we'll go level after level. S is from level 0, so we'll go for T, which is in level 1. So T is from level 1. They say that for us to manufacture 1 S, we need 1 T. That's why that 1 is next to T. So it means that to manufacture 100 T's, we will to manufacture 100 S, we will need 100 times 1, which is 100 S. What does it, which is 100 units? What does it mean? It just means that if I need to actually the product structure tells you how to go. It just means that if you need to manufacture 1 S, sorry, you will need 1 T. That's why we did 100 times S, because you wanted to manufacture 100 S. So for U, if we need to manufacture U, since it's also coming from S, so for us to manufacture 1 S, we need 2 U's. So initially we got 100 units of S, so it's gonna be 100 times 2, which is 200 units. So if we need to manufacture 1 S, we need 2 U. So if we need to manufacture 100 U's, we'll need, knowing that we need 2 U's to make 1 S, we will need 100 times 2. So we have done T, we have done U. The next step is to calculate for V. Like as I told you, start first of all level after level. We have done level 0, level 1, now we are on level 2. So in this case here, we need to manufacture, for us to manufacture 1 T, we need 1 V, then 1 V, I mean. So we look at the number of T that we need to make. In this case it is 100, so it will be 100 times 1, which is equal to 100 units. Then we do the same thing for W. W is coming straight after below T, so we look at T. For us to manufacture 1 T, we need 2 W's. So we look at the W here is equal to T, which is 100 times 2, which is equal to 200 units. Then after that we have TVW, so we have X. For us to manufacture 1 T, or 1t, we need 1x. So you come back to x in this case here, that is coming straight after t. T is still 100 units, so it should be 100 times 1, which gives us 100 units. So we have we got the values for v, w, and x. We go now to y and z. Y says that for us, remember now, don't count the 2 here. We count it when we are working with s, who is the parent. But when you are working with the children, we don't consider the 2 anymore. So as it means that for us to manufacture 1u, we need 2 y's and 3 z. So we go back to our table here. We need to manufacture y. Y is coming straight from v, according from u, I mean according to our structure here. We go back to u, which is 200. So we get 200 times 2. Y2, because for us to manufacture 1u, we need 2 y, which is gonna be 400 units. And then the last one, which is z. So for us to manufacture z, according to this table, it's supposed to be, for us to manufacture 1u, we need 3z. So we go back to our u's here. We look at how many u's do we need to manufacture. Is 200, so it's gonna be 200 times 3, which is 600 units. Now whatever we got here, it is the bill of material. So it tells us already that if you need to manufacture 100 units of s based on that product structure, you need to manufacture you need to have 100 units of t, 200 units of u, 100 units of v, and so on. All these values are based on the product structure. Now remember, in the very first part of the video, we talk about dependent demand. So which means that all the demand that are here, all the units t, u, v, w, x, and so on, the amount of unit that will be required from them will depend on s. Initially, this bill of material here is because we are talking about 100 units. If we change this 100 unit, we put it to 150 units, all the calculation below will have to change. So you understand that the demand of the component v, w, x, and so on will depend on the demand of s. If the demand of s is 200, the demand of all these other values will change. That's why we say that MRP is a dependent method. That's why we had to start with dependent method. So I think by now you now grasp a basic idea of why we call it like that, and how you solve the how you solve the bill of material. So now, after solving the bill of material, now we are going to come back to the question. The question was asking us to prepare a term-based product structure. So the term-based product structure is the same thing as the product structure, but at the difference that we add another component, which is the time, which is the lead time. Now remember what we said in the first video. We said that lead time, it is the time that is elapsed from the moment you have placed an order and you have received it. Now according to the problem, they say that finally each unit of U requires 2 units and so on. So one firm manufactures all items. So it takes 2 weeks to make S, which means that by the time you want S, you need to manufacture it, you need to wait for 2 weeks to get it. So 2 weeks is the lead time in this case. The same thing, they say that it takes 1 week to make T, it takes 2 weeks to make U, 2 weeks to make V, 3 weeks to make U, and so on. W and so on. So all the information that we have here are summarized in this table that I just did here. It is the lead time. So this table is important because it will allow us, whenever we are working for the product, for the term phase exercise. Now we will use it in this part here, which is about the term phase. I'm just going to put this table here. The information that we have here is the information from the lead time. How does it work now? For us to build the term phase structure, it is entirely based on the product structure itself. So we are working backward. First of all, the lead time is important, so we need to know when is sub-assembly S needed. Sub-assembly S is needed in week 7. So it is a key important when we are drawing our time phase. So you need to have 2 lines, 2 axes, which can be X and Y, is still fine, but it's just 2 lines. The horizontal line, that's where you put the time frame. In our case, we put 7 because this product is needed by week 7. So you start whatever they meet, that's gonna be the first week already, which is week 7, 6, 5, 4, 3, 2, 1. Remember that with this kind of exercises, we are working backward. We are working from the moment these items are needed till when they should start the production. Remember that the aim of MRP is to make a plan to determine when a product is needed and how many. Remember that based on the bill of material here, we know already how many, but now the term phase needs to tell us when it is needed. So in this case, how do we go about it? We just draw the same thing here, but we just flip it to go on the right. So in this case, we are going to start with S. So the component was like, we will start with S, that is made of two components, which are T and U. But now, how do you look at the information? You look at the information from the lead time that we have here. We need to start S, and according to the information, you can start it anywhere on the vertical line. And it is 2 weeks. That means that if S needs to be ready by week 7, we need to work it 2 weeks backward. So the first week it's going to go till where 6 is, and the second one till 5, where 5 is. So let me just use some grid line to make your calculation a bit more easy. So in this case here, this line here, it goes like this. So we skipped 2 weeks. 7 till 6 is the first week, 6 till 5 is the second week. So that's when S need to start. Based on the design here, I just want to use a line that is a bit thicker, so that you guys will be able to identify. We have something like this, and I'm gonna give it one color just for you not to be lost. So what we will have here is going to be called S, and let me insert the test. So whatever we have here, it is S, and then the lead time is 2 weeks, like this. So then from here, I want to remove the outline. Yes. So the first line that we have is the line of S, that is made, that is a lead time of 2 weeks. Now based on our component here, we say that S is made of T and U. T is 1 week while U is 2 weeks. So what you will do from here is like, you try to redraw again what you have done, which is the product structure that we have drawn there. So it has 2 components, and those components, based on what you want to do, while you are free to draw it with any measurement that you want, as long as everything fits inside, so it's still fine. I want to give the line this color here, and then big enough like this. So it is made of 2 components. The first component, we say that it is T, and the second one is U. So I can put T on top, and then I'll put U below. So, and T based on the lead time is 1 week. Remember, we are on week 5, so we'll have to draw it. It will go from 5 all the way till 4. I think 4 goes for this line here. So I'm gonna give it a green color, and I'm gonna give it the heaviest weight, which is here. So what we have here is T, like this. So I'll call it T, and then the lead time is a week. It's not 1 week anymore. So this is the first component. S is made of T, and what is the second component? The second component is V, if I'm not mistaken. It's U, sorry, and the lead time is 2 weeks. Remember, we are moving from 4 to 5 first week, from 5 to 4 first week, from 4 to 3, which is the second week, like this. And then I want to give it another color, like bit yellow, and the weight, to give it this weight. And this component here, we are going to call it W, no, it's not W, it's U, and the lead time is 2 weeks. So this information will be given to you whenever you are solving every exercise, as it, like in this exercise we had to pick it up. So what we did is, like, we solve S, that is 2 components, T and U. T, remember that the value between bracket here do not matter anymore. These values here, they were just there to help us build the bill of material. But when you are working with the When you are working with the time phase, you don't need that information. The information that you need is the lead time. So these 2 weeks here are not the values that are here between bracket. They are not. These are the quantities. These 2 weeks are the lead time that are needed. So this is what we have done. We have drawn S, that is 2 components, T and U. So we need now to draw from T has 3 components, V, W and X. So we are up here. What is going to happen with T is like we will draw another line that is 3 components like this. This component, well, let me just take a black color so that you'll see, to be able to be seen. Then we will draw the first component. The first component is V, and V has 2 weeks. When you look at the lead time, it is 2 weeks. So remember that we are on 4, so below there will go 4 and 3 here. So which is V? Which color am I going to give it? Let's try a blue, and the weight, I'm gonna give it the heaviest weight too. So based on this, we have T, that is 2 components, V, W and X. So we go back here, we will draw V. Whatever we have drawn is V. That goes for 2 weeks. It goes from 4 to 2. So we have 4, 3 and 2. That component is V. So we'll copy and paste here. We got something like this. Which one? This one is going to be called V, and the lead time is 2 weeks. Then the next thing is we draw the next component. Remember, T has 3 components. The next one is W, and then we have X. So I'm going to draw them all at once. So we are here. We have W goes for 3 weeks. So remember, this one was 2 weeks. We add 1 more week here. I need to check my table here below. Yes, so it's going from 4, 3, 2, and then it ends at 1 here. Which color? Let me give it a red color, and the heaviest way here. So the information that we have here goes for VW here. So W, this is the line for W, and it got 3 weeks. So we have done T as 2 components, V. I mean as 3 components, V. T is the main parent. Then we have V and W. And finally, we look at the last component for T, which is X. The last component for T is X, and according to this table, X is the lead time of 1 week. Then we look at our time here. We want to insert another line that will be for X, which is 1 week. That is living from 4 to 3 only here. And then which color? Let's take this color, and the heaviest way that we get, which is from 4 to 3. Then we will put our values here. The values we're taking it for X, that will go, so it's down here. The purple line here is X, and the lead time for X, was it X or W? So we have done W. Yes, it's X, so which is 1 week, like this. So T has 3 components. The first component is V, the second one is W, and the last one is X. So we found out that the values that is below gives you the information about the lead time. Then finally we go back to U, which is the last component that got Y and Z as component. So we start with Y and then we start with Z. So we're going to insert here a line like this. Then the color is the color from U, and the weight is the heaviest weight. So as a reminder, we say that the kit is Y and Z. So here we look at Y, it is 2 weeks, and we are on week 3. So we go all the way till week 2, which is the first week, and this one is the last week, like this. Then what we have, we put it the heaviest way. And have many colors. Well, I'm gonna use a dark green like this. And then what we have here, is the information for Y, and the lead time for Y is 2 weeks. So we have Y, and the lead time is 2 weeks, like this. Then the next thing, which is the final component, is Z, and it requires how many weeks? It's 1 week based on the lead time that we have here. Well, I'll put it later. I need first of all to draw it. So Z will come from you here. It's just 1 week. So you're moving from 3 to 2 like this. Then which color? Let me take this one, and then the heaviest weight. So what we have here would be Z. So we have Z, and then the lead time is 1 week like this. So now we are done with our product structure. I think I can remove now my construction line just for you to see it clearly. So from here we are done with it. You realize, as we started, I'm just going to try to summarize it a bit. As we have started, one thing that you need to do when you need to draw the term phase, the first thing is to draw an horizontal line that will meet a vertical line. Then from there you try to put your measurement, but preferably it's better for them to get the same length so that you don't get something that is just weird. So you always start from the intersection of the horizontal and the vertical. That's why you put the latest week. Here we took 7 because unit S is supposed to be done in week 7. So you put 7, 6, 5, 4, 3, 2, 1. Then you can start anywhere on a vertical line. Anywhere you can start below, you can start above, but just make sure that whenever after drawing everything, they will be able to fit. This is the most important thing. So we started with S. That is 2 weeks. This is the information that we get from the lead time here in our table. So this information, we got them in the problem. It was already given here in form of statement. Some other exercises they just give it to you straight in form of table, but in our case I had to draw the table first. So as 2 weeks, first of all, you find this information also in the product structure that tells you whatever you have like information. It tells you that S got 2 kids, T and U. You go back to your kid, you look at S, this is S, it has 2 kids, T and U. You give them the different work lead time based on the information that you get. S got 2 weeks, so it will move from 7 to 5. 6 is the first week and 5 is the second. Then we do the same for T and for U, and you'll be able to finish. Now you see that all our information, everything ends by week 1. If I want to lengthen this, you realize that by week 1 everything is going to be like this. Well, I'm sorry about this because it's slightly exceeding, but it's not supposed to exceed week 1. It's like this. So find out that by week 1 all the project needs to be done. Now if I had drawn my table with a line that exceed 1, like maybe like this, then there must be something wrong, because remember after 1 it's a week. We have week 0 and you cannot week negative 1, or even week 0, it doesn't exist. So everything fits within 7 weeks, from week 1 to week 7. So if we have to start the production, you will find out that first of all we have to start in the first week. We have to start with the first component, that is going to be Y. Here, that is going to be the first component, and this component we started from week 1 to week 3. By the time we have reached week 2, we have to start now with component Z and component V. Those are the ones that are starting from week 2, and so on until we have reached the final part. But so far, this is how you are supposed to draw the term phase, and this is all about this video. In our next video we will solve 14.6. we will ask us to construct a gross material, and 7 that will help us to draw a net requirement planning. So the next video will be made of the gross and the net requirement. But so far, thank you so much for this video. I really hope that it was helpful, and thank you so much again for watching. If this is the first time that you are watching this video on MRP, I'll suggest you to go back from the first video so that you have a clear understanding on everything that we are doing from the beginning till the end. So don't forget to subscribe to the channel, and you are free to comment if there are things that you don't understand. But the good thing is this is a video you can play, pause, run, and you will be on track. So thank you so much. See you next time. Bye.